Hey there everybody, I hope you're as excited as I am because in this video we are going to finish off the 2017 Pascal paper. We're on question number 25 and there is no more contest at all after this. There we go. So, Sam thinks of a 5-digit number. Sam's friend Sally tries to guess his number. Sam writes the number of matching digits beside each of Sally's guesses. A digit is considered matching when it is in the correct digit when it is the correct digit in the correct position. So we have a bunch of information. This is Mastermind. This is a game called Mastermind, basically. They just don't have the correct digit, wrong position information, but this is Mastermind. That's all it is. So it's just going to be a pure logic question. We're asked what is the sum of all the possibilities for Sam's number, so I'm guessing it's not a single number we need to work out. Sum of all the possibilities. I have a feeling this is going to be just a headache at the end adding things up, but we'll see. Okay, so I suppose I best write these down and we'll get everything all sorted. So 5, 1, 5, 4, 5. I'm going to separate the numbers a bit. And we have 2 correct. 2, 1, 5, 3, 1. And I had 1, 7, 1, 9. 7, 1, 7, 9, 4. That was 1. I think this was 0. Yeah. I'll just finish this off. 1, 2, 2, 1. Alright, and then 5, 9, 1, 3, 5. Five, 8, 3, 4, 2. 3, 7, 3, 4, 8. And 7, 1, 7, 4, 4. That sounds very similar to one we already had. Yeah, there's 9 and this 4 here. So, I think that means, actually, yeah. So, none of this one right here allows us to cancel off. So anytime I see a 9 in this column, I know that can't be the right answer, because if 9 was supposed to be there, we'd have 1 as our possible answer. Now, there aren't any other 9s in this column, but there are 4s. So 4 can't be correct. 7, that's out. You can't have a 1, so all these are out. And you can't have a 7 as the leading digit either. Now, notice here that places this 4. This 4 is correct. Okay? So, if I say, yep, there's going to be a 4 there. Now, this has, everything else here has nothing else that's correct. Here's the 4 that's correct. So now we've got 1 digit left that's correct here. 1 digit that's left correct here. Now, this 3 was not a 4, so we still have 1 digit left amongst these that are correct. Still have 1 correct here, and this 4 means that of the non-green things and non-red things, we have 1 correct. So, on this top one, we definitely have 5s. That's certainly a thing. And I'm going to get rid of this one. Okay. So, I know well, not my word, but Sam's word has a 4 as the second last digit. Okay, now where to go from here? Because everyone else has just 1 correct answer. So there's got to be a 5 somewhere in the number based on this first one here. So let us suppose for a second, we're going to use blue to suppose. Suppose it's this first 5. So this first 5 is correct, so any 5 I see anywhere else is incorrect. That means this 2 is incorrect, this 5 is correct, this 5 is correct, this 3 is incorrect. So now there'd be 0 correct digits in all of these. Still 1 correct digit here, so that would force a 1 here. So we'd have 5, we'd have a 1 here. That 1 is correct. But then that 2 is wrong. That's okay, we had nothing left here. That 8 is wrong. Well, we still have 1 that is left correct here. And so of the 7 and the 3, which one is correct and which one's wrong? Well, these guys have 0 correct digits left. So that means the 9 is wrong, being the second digit. 8 is wrong, being the second digit. 1 is wrong, being the third digit. 3 is wrong, being the third digit. And that means that this 3 is wrong as well. So we have to have 7 here. And that leaves a lot of options here for the middle. Now we're not done. Because remember, I made a guess. I said, what if that first 5 in that first number was correct? Maybe, and we'll have to get out like the orange or something, what if that middle 5 is correct? And then what if that last 5 is correct? Those are all possibilities too. But right now, I know that there's a chance that Sam picked the number that goes 5, 7, I don't care what, 4, 1. And because we don't care what's in the middle there, we have possibilities. Could it be 57041? Could it be 57141? We have a lot of different options here. So I'm going to say one of our sets of answers is 57A41, and A can be anything, but actually no. A can't be certain things. A can't be 1, 3, 5, or 7 because those were already crossed off the list. I had to be very careful. I was about to say A can be anything from 0 to 9, but that's strictly not true. Okay. So now let's copy what we already knew, and we'll deal with adding them all up at the end. I don't really need the 4 there. We'll include it anyway. A lot of this video is probably just gonna be me going back and forth and counting things again. Actually no, I used blue, so I can avoid that. Here, let's just say one of our possible answers is 5, 7, A, 4, 1, and A is not 1, 3, 5, or 7. Anything else will do. 5, 7, 6, 4, 1, that'd be fine. Okay. So now I can go back and change everything that I used blue on. So those would both be 1s still. Those would be 1s and 0s. 1s and not 0s. I could ignore this stuff here. This avoids me rewriting everything. So we had a whole bunch of 5s. Five, 5, 5. 3, 5, 5, 2. 9, 8, 7, 1, 3, 3. And 5 here. And a 1. And then 5, 2, 8. And that's all we did with the blue. And I will just give it a cursory once over this. Everything looks okay. So now we're going to say this 5 here was wrong. We're going to keep it in blue, but this 5 here was absolutely wrong. So it could be a 2, could be a 3, or maybe that the first one is open for debate. So now let's use purple and say that this 5 here was correct. So now this will be the purple case where the 5 in the middle was correct. So that means this is correct, this one's wrong, so that means this 5 is wrong, and each of these is wrong. So these guys go down to 0, that means this 2 was wrong, and this 1 is wrong. We're left with 1, 1, and 1. Everyone can still have 1 correct. Now, there are no numbers in common, and this 9 is the only thing left here. So this 9 has to be correct, which means this 8 and this 7 are incorrect. The only thing down here is this 3, or the only thing in the first row is this 3, so that means this 8 is incorrect, and that means we get a 2 here. So 3, 9, 5, 2, that's only one possibility. Okay. But that wasn't so bad, actually. So we'll do 3, 9, 5, 4, 2. I think there was a... Yeah, the 4's got to be there. It was 3, 9, 5, 2, right? Three, 9, 5, 4, 2. Okay. So now I just have one case. I'm hoping it goes as quickly as this purple one did. But now we're going to assume that this middle 5 was not correct. Nine, 8, 7. That's 5 and a 1. 5, 2, 8. If you didn't have colored pen, I'm sure you probably had enough rough space to make a number of these. I think it went 1, 3, 3, but let's just double check. Oops, wrong thing there. I think it went 1, 3, 3, but let's just double check. Yes, 1, 3, 3. Okay. So 1, 3, 3, and now we can, we've got to get rid of those purples in just a moment. We know that the middle 5 can't work. Alright, so everything else here is 1s. Okay, so now that those 5s don't work, in orange we know this 5 must work, and that means this 5 must work. So this 1 is wrong, this 2 is wrong, this 8 is wrong. So now we've got 0 left to be correct in here. That means this 2 has got to be correct. So that means this 3 is wrong. This 5 correct, and there being only 1 correct there, means that this 9 and this 1 are wrong. And both of these have 1 left correct. Now, suppose that one of the correct ones wasn't this 3. Then the 8 would be correct, and this 3 would be incorrect, and then this 3 would be incorrect, and then this 7 would be correct. We have a problem. So it's got to be the 3 that's correct for both of them. So the 8's not allowed, the 7's not allowed, and the 3 is correct for both of them. And that brings everything down to 0, so we've got 2, blank, 3, 4, 5, and we'll call this guy B. B can't be 1, 7, 8, or 9. 2B, 3, 4, 5, and B can't be 1, 7, 8, or 9. Alright, so we've got all the possibilities expressed, and finally we're just asked, add them all up. Okay. I'm going to add them up in sort of an unconventional way. I'm going to leave the A's and the B's out, treat them as though A and B were 0, and then we'll add up the B thousands and the A thousands, just to get a rough idea as to what the answer should be. You, of course, might do it a different way. You might actually list out all the possible A's. But, so A is a single digit, and they can be, they can be zeros. There's no restriction that they have to be positive digits. So A can be 0, 2, 4, 6, 8, or 9. So that's 6 possibilities. So we get 6 times 5, 7, 0, 4, 1, plus 100 times the sum of all the A's, plus 39542, plus, and then 4 possibilities that B can't be, so that's 6 possibilities that it can be. And we're going to have to add on 1,000 times each of the possible B's. So 0, 2, 3, 4, 5, and 6. And those should be added, not commas. All right. So we'll break this down. 17 plus 10 is 27, plus 9 is 29, so 2,900. And 5 plus another 5 is 10, plus another 10 is 20, so this is 20,000. Okay. And grabbing the calculator now, 6 times 57041, 342246. 39542 stays where it is. 6 times 20345 is 122070, and we add on to that all the other numbers. 342246 plus 2,900 and 20,000. And I get a total of 526,758. 526,758, and that's looking like it's E. So we're going to say E is our final answer on the final question of the 2017 Pascal. Thank you guys, as always, for joining me. If you'd like to, there are going to be more math contests from 2017 appearing shortly, so feel free to subscribe to be kept up to date. But either way, I will see you guys for more math contests in the future. Thanks for watching.